Check, check, check. All right, here we go, Chapter 4 review. I'll do the first three as this video. This is just finding the area in between two curves. Let's see the directions. Do number 1 by hand and use a calculator for 2 and 3. Okay, first thing we're going to do is graph these. All right, so to graph the first one, again, I'll give you something a little easier to do by hand without a calculator. But again, you'll have a calculator for the entire test, so you can see what this graph looks like. But you could factor this into x plus 1 times the quantity of x plus 1 and see that the zeros are at -1, which means there's a double root there at -1, which means it's a parabola that double roots hit that point and bounce back up. All right, so there's f of x. All right, the second function is g of x is y equals 3x plus 3. So, I don't know, something like this up at 3. And it's going to go down to, and this graph actually goes right through that point. All right, there's g of x. And we're going to find the area in between the curves. Remember, we're just finding the area in between the curves. We're not rotating it or anything. Okay, so the next thing is we're going to find our lower and upper bounds for this. So our lower bound's -1, and our upper bound is this point here. Now my graph might not be exactly correct, but to find that lower bound, I'll set these equations equal to each other. So x squared plus 2x plus 1 equal to 3x plus 3. So that's x squared minus x minus 2. So x minus 2 and x plus 1, so at positive 2 and 1. So this is actually on the other side of the x-axis, but that's fine. Or this side of the y-axis. Okay, so now we're going to do this to find the area. We're just going to do top minus bottom. So the area is going to be equal to, we're going to integrate from -1 to positive 2 of the top function, which is 3x plus 3 minus the bottom function, which is x squared plus 2x plus 1 dx. All right, I have to do this one by hand, so I'm going to simplify that before I integrate it. So the integral from -1 to 2, that's going to become an x. That's going to become a plus 2, and then a minus x squared dx. All right, now I can integrate. So x squared over 2 plus 2x minus x cubed over 3, and integrate from -1 to 2. Alright, so f of b minus f of a. So the first thing we'll do is put 2 in, so that's a 4 divided by 2 is 2, plus 4 minus 8/3, minus, if I put -1 in, that is going to be 1/2, minus 2. That's -1/3, but the negatives will make it positive 1/3. Alright, let's see. This 2 and that's going to be a positive 2. That'll give me a 4. Plus that 4. A -8/3 and a -1/3 is a -9/3, which is -3. And then a minus a half. I'll come over here and do this. So that's going to be 8 minus 3 minus a half. So that's 5 minus 1/2. It's 4 1/2. 4 and 1/2, which is 9/2 units squared for the area for the first one. Okay, on to the next one. Alright, number 2, we can use our calculator for this one, so I'll just graph it. So the first one, cube root x plus 2, so it's shifted up to 2, and it's a cube root graph, so it looks something like this at half. Don't really need to be too concerned about that. Y equals x plus 1. There's a graph that goes through here like this. I guess you should be labeling that's f of x, that's g of x. X equals 0 is this line, and then x equals 2 would be some function that's here. And then the area is this stuff in here. Alright, so next thing, find the upper and lower bounds. So my lower bound is going to be where x is equal to 0. And my upper bound is here at 2. I believe the answer key online says 6. Thank you, Erica Rummel, for making note of that. So that's a 2. Okay, so now I can write my integral for the area. So we're going to integrate from 0 to 2. The top function, which is 1/2 x cubed plus 2, minus the bottom function, which is this piece here, which is x plus 1 dx. And again, you can use your calculator for this one. So when you use your calculator, the answer ends up being area equals 2 units squared. So the answer on the answer key is correct, but the upper bound I think said 6, and it should be 2. Okay. All right, next one. All right, the third one. Now again, these are x equals. So you're going to have to know how to graph these, because you're not going to be able to do it on your graphing calculator, because it's x equals, not y equals. So the way we're going to do this is exactly the way we do it if it was y equals, and these were x's. So I'm going to factor out a y, and I get 2 minus y. So 0 and 2 are my y-intercepts. So at 0 and let's say 2, which is right there, and it's going to look something like this. Opens to the left because the y squared is negative. And then the next graph, which is really just y equals negative x, which is this graph like this. So this is y equals negative x, and that's the other one. All right, and we're going to find the area in there. Now, since everything is in terms of y, I'm going to do right minus left for this. All right, so we're going to do right minus left. So to do right minus left, my lower and upper bounds are going to be the y coordinates of the points of intersection. All right, so this one's at 0. Now my other one is this value here. Please don't choose 2. So I have to find out where they... Time out. All right, I think I'm back here. Again, the monitor went to sleep and everything shut off for me. Okay, so to find the b value, I'm going to set these equal to each other. So I'm going to set 2y minus y squared equal to negative y. Let's see, negative y squared equals, I'll move that over, so that's negative 3y. Divide by y. It's going to be y is equal to 3 once I simplify that, so my lower bound is 3. All right, so now we're going to do the area. So integrate from 0 to 3, and it's right minus left, so it's going to be 2y minus y squared minus negative y dy. And again, you can grab your calculator for that, and you should get your area is equal to 9/2 units squared, which is obviously, or 4.5 units squared. Okay, so that's the first 3 just area problems. Then I'll do the next 3. All right.